Welcome back. Today we're going to look at multidimensional arrays. So we saw how we can use an array to store a collection of values or numbers or strings, but you can also not only have just a list in one dimension, but you can have them in two dimensions. So imagine if we wanted to represent a table, we could represent that perhaps with two numbers, one representing rows and one representing columns. And the syntax is the data type, the array name, and then two sets of square braces with rows and columns represented. So for example, if we wanted to store a collection of integers in a 3x4 grid, that would be represented this way. If we wanted something to represent an image on a screen could be represented with an array of ints with 640 by 480 if that was the size of your screen or your image. If we wanted to represent three dimensions, we would just add another set of square braces. And so in this case, we want we have a weekly weather grid storing data. It has 256 by 256 by 7 elements. So we can represent any number of dimensions, 1, 2, or 3, just by using a different number of square braces. So let's declare an array of integers with two dimensions called lot number, and the dimensions has 15 elements for dimension 1 and 12 elements for dimension 2. So pause, think about or write down your answer, and then hit continue. So in this case, we need to put the type. It's integers, so we put int, and it's called lot number. And we have one dimension in 15 and another dimension in 12. So that's our two-dimensional array. Let's declare an array of floats with 4 dimensions called tesseract. All dimensions have 3 elements. So 4 dimensions is hard to envision, but the computer doesn't really care. You can put as many dimensions as you want. So try to define this tesseract. So pause, write down your answer, and then hit continue. So again, you just follow the same process. It's an array of floats, so we put down float. It's called tesseract. And it's got 4 dimensions. So we just write it in 4 dimensions. Now, if you can visualize that, that'd be wonderful. But, you could have all kinds of problems with multiple dimensions that could be represented with this array. The computer actually stores all arrays as just a continuous sequence of numbers and just uses the indices to go find the element that gets stored in it. So it doesn't really care how many dimensions are. And in fact, this structure is really just for us as human beings to visualize what's happening. So once we have a two-dimensional array, can we initialize it like we did with a one-dimensional array? And in fact, you can. And this illustrates the fact the computer stores the information really just as a one-dimensional array, even though we are thinking about it as a two-dimensional array, and we represent it in our code as a two-dimensional array. We can see here that we have a grid. This has 3 elements by 4 elements. That's a total of 12 elements, and we can see that we have 12 elements stored in the initialization. And, if you wanted to, you could use the fact that in C++ it doesn't care about how you use your white space, so you could put carriage returns to kind of visualize this table, if that makes it easier for you. And so, this is what's being represented in the computer, and this is how you would visualize it. Perhaps, if we were looking at grid 0, 0, that'd be element 1. If we're looking at grid 1, 2, that's element 7. And the way it does that is it takes the first element and multiplies it by the number of elements in the second one. So that's 4. Adds in the index, so you get 6. You have 0, 1, 2, 3, 4, 5, 6. That gets element 7. So it really gets there through a multiplication process. Declare a two-dimensional array of chars called letters with 2 elements in each dimension, and we're going to initialize the A, B, C, and D. Again, pause, write down your answer, and hit continue. So in this case, it's a char array. It's going to be called letters, and we have 2 dimensions with 2 elements in both dimensions. And then we use the curly braces. And we're going to, and these, since they're chars, these have to be in single quotes. And that's our array in 2 dimensions. The next question is, how do you loop through your arrays to get to, in 2 dimensions, to get to your values? So, with a one-dimensional array, you have usually 1 index. With 2-dimensional arrays, you're going to need 2 index or indices. And it's a good idea to name those arrays those indices appropriately. You could go I and J, but sometimes row and column makes more sense. And you can name your indices anything you want. So in your for loop, name those indices something logical. So in this case, we have a grid with 100 by 50 floats, and here we're going to declare our indices as row and column, and we'll say for row equals 0 to the first index, and then column equals 0 to the second index. And here we're initializing them to 0. And so the first loop will go from 0 to 50, and that will hold a row as index 0, and then it'll come back out, row will become 1, and then it'll go through 0 to 50 again, then row will become 2, and column will go to 0 to 50 again, and it will get through the entire list. .11. So let's look at program 6.11. So here we have our bingo card program. I'll run it just to see what it does initially. And we see it generates a bingo card. And it's making different ones. Or no, actually it's creating the same one. But, this card, you can see, could be represented as a 5 by 5 array. And that's exactly what this program does. We have a 5 by 5 array being declared of integers. And then a loop is created with column and row. And notice that here, because the center of the bingo card has to be a particular value. It's this value here, free. That it looks to see, it checks to see if it's that element. It goes to 100. They use the continue to go back around and get the next element. Otherwise, it sets a random value into the bingo card, and then to whichever row or column it's on. And the value will be between 1 and 15, and it multiplies by the column because that's how bingo cards are generated. And then after it's completed making the bingo card by filling in this array, it creates an array for the top elements, and then goes through and prints out the card. So it goes through the rows, goes through the columns, displays free here, and then it'll be displayed. So that's an example of using a 2-dimensional array to represent a bingo card. Next, just like regular arrays, they can be passed to functions. One of the wrinkles that happens when you have to pass a 2-dimensional array or a multi-dimensional array to a function is you must specify all but the last value's dimension size, and that's so that the function knows how to access elements in that array. So, for example, let's say we have these two arrays. One's an array of ints that's 16 by 10. Another one's an array of ints that's 4 by 40. They both have 160 elements. But for the function to know how to treat one of these arrays, it needs to know at least one of the dimensions. And so when you pass an array to a 2-dimensional or a multi-dimensional array to a function, the first one can be empty, but the other dimensions have to be specified. So let's look at program 6-12. Here we have two functions being defined, print card and fill card. And here's fill card, and you can see we pass fill. It's the same program, but we're doing this with functions. So we're going to call fill card and then print card. With fill card, notice that we have to specify one of the dimensions. We can't do it this way. In fact, you'll get an error that says an array may not have elements of this type because you have to specify one of the dimensions. You don't have to do this. But you must specify all but one of the dimensions. And then it takes that and it does its work with the array. Remember, arrays are implicitly passed in by reference, so that's why this is void. It doesn't have to return the array. This will actually modify this bingo card array being passed in. So a bingo card, which is a 5 by 5 array of ints, is being passed in to this parameter called bcard. Bcard then gets filled with this function, which does the same thing as it did in the other one. And because bcard is passed in by reference implicitly, bingo card is also filled by this point. And when we pass bingo card to the print card function, again, it's passed into a parameter called bcard. This will display bcard because it's passing by reference. Bcard is basically the same thing as bingo card, and it gets displayed. So that completes my review of 2-dimensional arrays. Thank you very much.